In this topic, we're going to talk about performing an enterprise security analysis. So we'll look at terms like benchmarking, conducting network traffic analysis, the different types of networks that you have to work with, and analyzing the traffic as your network is designed. Prototyping, testing, cost-benefit analysis, sometimes people call return on investment. The different type of strategies for security analysis, for the security solutions, how to make sure that you know how to do an enterprise-wide security analysis, being able to use that information to review your existing security, especially what I would say is comparing it with your existing policies. We're also going to look a little bit about some types of reverse engineering, being able to look at the attributes of your different solutions, and when it's all done, having the after-action report, which really is kind of what you're getting paid for, right, is to show that documentation. Hoping that you see some of the common best practices or guidelines for the analyzing scenarios that you would use to secure the enterprise. And then when it's all said and done, hopefully you've learned something. And by the way, we want to be able to make the network more secure. It's important we understand we're not trying to pick on any one part of the company or any one person's job or how well they did the job. Everybody can benefit from these types of audits. And so at the end, finally, the hope is we can take everything we've learned, what we call lessons learned, review it, and make improvements. So benchmarking here, as you can see, it is a method of providing your organization to be able to compare its business methods and security plans and practices against other organizations as a way for you to review how effective your existing security is and help set standards for your methods, plans, and practices. So what we're doing here is basically getting some information, right, that we can use to compare. We can also use our benchmarking to create a baseline and even use that baseline as our benchmark, like I said, to detect anomalous data traffic and patterns in your enterprise. So when you conduct a baseline analysis and evaluation of the network data traffic and the patterns under normal use, then that's your benchmark that you can use to make comparisons going from there. So, here's an example, I guess. We could say, here's company A, and, they've seen some phishing attacks, some farming, some spoofing, and we can say, okay, that doesn't really look like what we want. We want to have a better baseline or benchmark, obviously a reduction. So we use that information, the fact that we can say, hey, that just isn't hitting the baseline or the benchmark that we want. So we'll do something to maybe, something similar to what company B might be doing, or, however you want to look at it, but say this is our goal. This is where we want to get to. And so we could look and see what company B is doing if they tell us about it, and we can see, that they have a lot lower number of attacks in those same categories. So we can say, all right, that's where our goal is. We want to take that as a benchmark and apply it so that we can get there. Traffic analysis is basically a way of doing what we would call a packet capture. We often call them PCAPs. There's a number of different tools that you can use. This is an example of one that's built in with some of the older versions of Microsoft called the Network Monitor. And of course, we can download some tools. One of my preferences is free, called Wireshark. I mean, it's very impressive. I think you'll like it, probably even better than the one you see here. But the goal is if you think about it, running this at least on a PC, what you're looking at this point is that it's attached to the network card on this PC, so any traffic coming to or from that PC is what we're going to be seeing. Another type of analysis where you could use something like Wireshark is you could take one of your switches, and it may have regular traffic moving through the switch, but we can do what some people call port mirroring, or Cisco calls it span. Again, just doing a packet capture. And you basically, as the traffic's moving through the switch will take a copy of that traffic and send it to out through another port, where you could have a computer there acting as a collector, running again something like this Network Monitor or Wireshark, acts as a collector, and then you'll see all of the traffic that's moving through. From there, what you're actually going to find is that you're going to see each frame as it's going through, and you can click on any frame and look at that information in more detail. So in this case, they clicked on frame number 4. We see the source address. Destination address is the computer that it was captured on. and we can see the protocol, in this case ICMP, so it was probably some sort of a ping. And in fact it was. I can see it down here. Once you click on it, then there's usually a place where you see the details. So you can look at layer 2, you can look at layer 3, IP version 4 address, and you can see layer 4, ICMP message. It was an echo reply. The other nice thing about this is that if you wanted it to, it'll show you the hexadecimal values, but it will then convert them into the actual words that we can read, so we know what kind of message it was. When we talk about the types of network traffic analysis, the first one is static. And that to be able to do that, it means that when something changes on your enterprise, like adding a new application or a new server or a switcher router, that we can get a baseline, which you can compare subsequent traffic analysis to determine anomalies or attacks or just changes really in network traffic. So again, I guess the idea is, if I have a couple of routers out here, and they're connected through a switch, maybe a few other switches in this segment, maybe not the best diagram or what have you, but we're watching the traffic, we're seeing the direction of traffic. Maybe it's been coming in here and always lots of traffic to this particular server, and then suddenly you add a new server, and so the traffic analysis can start to show you the changes in trends of traffic. Maybe the addition of the extra server is increasing the traffic. Now that doesn't necessarily make it an anomaly, but you can see what's different. If I didn't add a new server and suddenly I saw traffic coming out from the World Wide Web trying to get into my network and get to that server, and I haven't seen that for the last 3 months or as a part of my baseline, then you could say, yeah, that's definitely an anomaly. The dynamic network traffic analysis is something that's triggered by security policy or event to help identify and responding to changes in network settings, configurations, or incidents. So I mentioned there's a couple of firewall products out there, and one of the things that's really cool about these, some of these next generation firewalls is, let me just put a couple of ports on there, is that traffic comes in, goes through security policy, goes out of the firewall, and some of them will do, like I said, that AV scan. And let's say one of those packets matches a signature for a virus. That's when suddenly this firewall could trigger off a packet capture. So as it's blocking that traffic, it's capturing it. So you can open it up later as a PCAP file with your Wireshark and be able to do an analysis about where it came from, where it was trying to go. So that's something, like I said, it's not always on, but can turn on when it sees a threat. Continuous, of course, is just that. It's used sometimes for updating, logging, and alerts for traffic changes. And generally speaking, that's where the SIMs would come in. So let's call this the SIM. So, or, let's say even NetFlow. It's kind of a more of a NetFlow, unlike a SIM, is looking more for averages and aggregating totals for you, whereas SIMs are looking at the detail. But either way, these devices can collect all that data information from the routers or even from your PCs and servers or wherever you want to send to that SIM, and depending on what the SIM can do. And then it can, again, trigger an alert for you, but it's constantly monitoring or getting copies of that traffic. So prototyping and testing, especially as a solution for your enterprise security, allows you to model one or more solution scenarios. So you can test hardware and software, security tools, maybe your processes, policies, and some or all software prototyping is usually done in an enterprise sandbox. And what they mean by that is that you're over here in kind of a lab environment where you probably block all the traffic so that whatever you're doing over here during your test isn't going to affect the production network. And that's where most of our prototyping and testing is going to be done. And it's a great way, especially if you can make the lab over here look like the production network, which in today's world of virtualization is also pretty easy. You could also use it as a POC or a proof of concept type of setting, or demonstration, whatever you want to do. But that's kind of the idea of prototyping and testing, making sure that things look secure and run right before you throw it into the production network. So when we sometimes do risk analysis, CASP. One of the things that we're doing is looking for the potential of threats and trying to make some determinations if those threats with the use of mitigation actually give us a good return on investment. And sometimes that we call that a cost-benefit analysis. And I know that we've talked about this before, but let me just think about it like this. Again, let's say I have a building, and I know that building was worth $1 million. Expensive building, and then we look at the exposure. What would happen if there was a fire? So maybe somebody says, well, if there was a fire, we expect to lose 90% of the building. So that it would be, one incident would cost you $900,000. And then we might look at the rate of how often fires break out, and maybe for the building design, whatever actuary table that you might see. And let's, this is a ridiculous number, but let's just say that over a 10-year time, you're going to expect to see a fire. Okay, so I say that because I wouldn't want to be in a building that I knew might burn down, but let's say that happens. So I know that over 10 years, that each year I have a 10% chance of that fire occurring. So that means that, I'm looking at, if I annualized it over 10 years, that I'm looking at like a $90,000 expense. So now we look at the cost of mitigation, and we said, okay, what would it take to put, save us if we put sprinklers in there? Maybe it's that old of a building that sprinklers weren't required. And we say, okay, if there was a fire and we had sprinklers, now we're expecting our loss to only be $50,000. And we still might have that 10% chance, but now we're talking about, worrying about $5,000 per year annualized if there was a fire. And so that's an $85,000 savings. Now the question is how much do the sprinklers cost? Let's say the sprinklers only cost $10,000 to install. I mean, I know I'm coming up with ridiculous numbers. So even if I just added that, and if I even annualized that out over time, you're basically asking the question now, is $1,000 annualized per year worth it to save me $85,000 per year? And in this particular case, I would probably say, yeah, that seems like a pretty sound investment. So that's a part of what you do with the cost-benefit analysis. So let's take a look at some of the strategies for security analysis. So again, this is more of a review of everything we've already talked about. So you should, of course, conduct an updated risk assessment. The risk assessments are helpful to help you understand where you see the threats and what you can certainly use to help create a policy or to choose the type of mitigation you want to use. Again, evaluate your network traffic for traffic pattern changes or flow changes. And by the way, that might not be, like I said, because of a security problem, but just because of a change in the way in which the network's being used. And you can use that information to make a better network. Always, again, reverse engineer and deconstruct your existing solutions. Evaluate your log files across many resources. Like I said, be proactive with those. Make the baseline or benchmark so that you know what normal types of events are or normal expectations of traffic or threats. You can use that as a part of your security plan and practices. If necessary, you can outsource a network security analysis. Again, constantly do review your own research for security threats, vulnerabilities. Review the new and emerging technologies. Review solutions that different vendors have. Go to some of the conferences or some of the trade shows, see what else is out there that you might not know about. And of course, with all of this, you're going to have to use good judgment to solve difficult problems. When we take a look at some of the analysis of security solutions, first of all, you've got to have a goal. Specify the performance that you want. That includes latency, how long it takes a packet to go from end to end. Can your network be designed for scalability? I mean, you design a network now or a security solution now, In 5 years, will it still be good? In 2 years, if your company growth doubles, is it scalable? What are the capabilities, the usability, and of course maintenance? That's another big part of it. And also we're worried about availability. Remember, availability means we always have communications. You might look at things like redundancy to your routers perhaps, or the use of clustering for availability. Some of these things like maintainability, you're going to get that from the vendors or from the experience of what you have. But we want to look at all of those as we're doing a decision about analyzing how security is working as a solution. All right, so as a review for the lessons learned, we said that you should include enterprise security analysis, provide some insight into the enhancing your security, look for the gaps that you have in security, and then of course also evaluate changes you made to maybe get rid of some of those gaps or to enhance security based on the analysis that you've done. So again, as a review, when we talk about how to perform the enterprise security analysis, again, benchmark your enterprise security plan, analyze your network traffic against that baseline, look for the anomalies, look for changes. If you see some needs that or some things that need to be changed, again, test those security solutions, look for vulnerabilities. Again, some of those choices that you want to make, go through the cost-benefit analysis to see if it's worth it. Again, look at different strategies so that you can thoroughly analyze your security needs. Rigorously evaluate 2 or more security solutions as a choice. Don't just say, well, we've always bought brand X, so we're going to stick with brand X. Brand Y might have something for you. And then identify and document the lessons that you've learned and the outcomes of the actions that you took. So one of the things we should do is review the existing security. Again, having this done at least yearly, if not more often, is giving us some consistency so that we know that we're getting the right return on investment for whatever controls we've put in, and that we're meeting our policies or our baselines of what we want. That's where we would say, at minimum, you would conduct this every year. Whether it's done internally or you have somebody from an outsourced company come in, either way, at minimum, it should be done yearly, if not more often, especially if you introduce new technology. Then we would certainly want to speed up the process of getting those reviews done. Also, part of that, right, is to look at or perform vulnerability assessments, at least again internally, if not by a contractor coming in. Use penetration testing to give you a little bit more intense approach. And really a penetration test is really trying to pretend like you're the hacker and following kind of the methodologies that a hacker would go through to be able to try to break into your business. And the reason is not so that you, well, we hope that you're not successful breaking in, but that at least you can test to make sure that you know what the hackers out there are going to see. And if you could break in, well, guess what? That means these other groups could probably do the same thing. But at least you know about it, you can try to fix it. All right, again, we want to try to do full internal audits and again, review the systems and the processes that are behind those systems. See if what you really assume is your security, that it is performing the way you expect it to. And I'll one more time say it, make sure you compare that to the policies or the standards that you're trying to reach. One process of looking at how software attacks might occur is this idea of reverse engineering. Reverse engineering is a method of trying to take a package of code and, if possible, to break it down into the actual source code so that you can see what step-by-step is being done within this program. Not everything is going to look as nice and neat as you see on this picture as we're breaking down a Java type of script. Some reverse engineering might be that of compiled code, and all you'd end up with over here is a language that we call assembler. And it's not as easy to read, but you can still see what's happening step by step. But the goal is to be able to take the existing running program, break it down, and make sure you can analyze it, or if that's not your skill set, to have somebody else analyze it and give you an idea of what's happening. Now, here are some other things that I would look at. When I am actually looking at these, I might look at these variables to make sure that they might not be subject to a buffer overflow, to make sure that there's something we're doing inside of the code to make sure the information being put in is correct. And that's a big thing as well, because some SQL injection commands would not be what I would call a regular, let's say, username field, because it's going to use hyphens and semicolons, and so I would look not only to see if this is doing anything malicious, but to make sure that it looks like it was designed with security in mind. When we look at the attributes of our solutions, what we're going to be looking at is, and again, a solution, right, is to fixing security. We want to make sure that we're looking at issues like the performance. I think I've made mention before that some security solutions or controls might actually slow down the amount of bandwidth that you have. What are we doing about availability? Not only just a single point of failure, backup paths, redundant equipment, but also making sure that things are not so secure that we're not getting the information we want. We're going to look at latency. Are we slowing things down, especially big on real-time applications like voice or video? The capability of the device. Does it set up and be ready to grow with your network? Scalability. Usability is another issue. A lot of vendors, of course, are trying to make it very easy and intuitive to be able to utilize their GUIs or command lines. To me, that's a part of usability, as well as knowing where it goes in the network. Then we have to look at the maintainability. To me, I just call that the ability to update it or upgrade it. And, of course, recoverability in case something crashes. All of these are attributes that we should be looking at and researching, I would say, for every security control that we want to use. Now, the after action report, I told you, is something that you get, really, is what you produce to get paid if you're an outside contractor. What it should say is what actions did you take. It should say is the, this the best or most optimal solution. And again, remember, there may be even better solutions, but on those attributes might take and create more latency, might reduce more bandwidth, right? So we're trying to balance all of those. We should be able to answer questions like, are there more capable solutions? Either more capable for something you to purchase or more capable than what you already have. How well did the security teams react? Now, this is a good one. If you're doing a penetration test, you shouldn't just do it in the dark. What I mean by in the dark is you should let the security teams know that you're doing the penetration test so they can also practice on how to detect those types of intrusions. So how well did they react to that? Then maybe ask questions or put in statements about how you might respond differently in the future. And then, of course, should maybe the policies change in light of any of these other answers, especially when we're considering all those future trends and everything else I've talked about. All right, so let's look at the guidelines for the analyzing scenarios. One of these, of course, is we talked about baselines. Remember, to me, a baseline is that minimum security that we want for each system. We can be better than the baseline, but we want to be able to be at least at that baseline. Make sure that we know how to measure the types of things that we're auditing. Again, the measurements should be something that's relevant and effective for being able to compare those measurements with your baseline. Again, looking at routines of hopefully more than just once a year, but doing the benchmarks. The benchmark, again, is just your measurement on a system, and make sure that it at least is as good, if not better than the baseline. You may, and I would suggest you do this, prototype and test these solutions before you implement them. That's where I hope that you have a lab or maybe even a virtual environment that you can emulate your network with and see what this new tool or solution might do to that existing environment. Now, and having said that, depending on how many devices or controls you're going to purchase, your vendors may often conduct what they call a proof of concept or a POC, and that means that they can demonstrate a live environment test for you. In many cases, the vendors will try their best to recreate your environment and then give you that proof of concept part. All right, also return on investment, total cost of ownership. Again, total cost of ownership, if it's something new, that means you may have to train people on how to use it. You may have to buy more supporting equipment to be able to make this happen. You may have to look at the license fees and the services and everything else. And then when we look at all of that, ask the question, is using this equipment in the long run going to save me money and time? And by the way, total cost of ownership, you might be able to measure by uptime so that you can say, well, okay, yes, I'm making a financial investment, but I went from 3 nines of uptime, which would be 99.9%, to 4 nines of uptime. And let me tell you, that's a big difference, even though it doesn't sound like it when you consider it over a year. Anyway, just make sure it works with the cost-benefit requirements. Again, gather information or collate information from different sources so you can look at these different trends in security. Be skeptical about trusting unverified information, as I said before. Don't fall for a hoax. Look at how effective your existing security controls are. Certainly a vulnerability assessment or a penetration test, and that's a great way to verify that you're getting the security that you think you have. Using yours or a group of people's judgment to help solve difficult problems that might not have a best solution. That's another one of those trade-offs that you might have to go through. If possible, reverse engineering your systems, your scripts, your code, to make sure you understand what their behaviors are. And as I said, the after-action report, questions to ask to help improve security, analyzing the attributes, as I said, latency, bandwidth, and those types of things. And then hopefully after all of that, you should be able to hopefully put in best practice implementation, maybe even automate some of that through scripting technologies. So in this lesson, we talked about the security research and analysis, and a lot of it was to help us understand how to test, how to analyze, how to make reports to help improve security by doing research, looking at trends, taking a look at impact analysis, and then we talked about how we would take that information and perform the actual enterprise security analysis.